Steel frame construction. In this presentation, we will study iron products, steel history, some advantage and disadvantage of steel as a structural material. We will learn about the different type of steel sections and other steel products. Iron is a natural element that is found on the earth and has been used for many years. Iron ore is mined from the earth, is heat at very high temperature, and after its blast, some impurities will be removed. Then can be cast, usually in some little pieces called peaks, and can be redeveloped in other type of material. The first material that was used was the cast iron, thereafter was transformed as a ground iron, and finally steel. And now we have many types of steel, but in the past, cast iron was the typical material. Cast iron is formed after remelting this pig iron, and the material is put into molds. It has a high content of carbon from 2 to 6%. That carbon made the material a little bit brittle, what is not convenient, however, is used for make machine parts, engine cylinders, blocks, stoves, pipes, radiators, etc. It was the early form of ferrous metal that was used with iron, and the problem is the high content of carbon. The first structures with cast iron were made in the late 1700, but because it's brittle, it's difficult to work with, cannot be welded, and it's difficult to shape except if it's melt and we have a mold. Thereafter, ground iron was developed. This is refined with a converter that is called the Bessemer and is poured, and finally this material can be even squeezed and make some kind of rolls and make like surfaces that are very flat. This material is tough, is very easy to work with, is ductile, is corrosion resistant, and melt only at a very high temperature. Well, it was used as a structural material for frameworks, but when the steel was developed, this material is used only for ornamental ironwork. The most famous structure that was built with ground iron is the Eiffel Tower in Paris. It was made completely of wrought iron. It has 18,000 pieces and 2.5 million of rivets. What was incredible in the moment that this element was built, this structure was built, is that the construction was very fast. We can look here the 15th of March of the 88, and after in March of the 89, the building was ready. Well, the full tower took 21 months, and that was something that if you imagine the year and imagine the height of this tower was something that was incredible, that was very difficult to do at that time with any other material. Remember that at that moment, concrete was no use. Well, steel was a material that seems like be miraculous. Steel later on, that was with wrought iron, but now steel was developed later on and is an alloy of iron, carbon, and other elements. And the idea is to make a material that is stronger. This material was not economically produced until the Bessemer furnace was invented and started to be produced on scale in 1850. And the idea was to blast air into molten iron to remove the impurities. Steel is classified according with the carbon content. High carbon steel is hard and brittle. When there is very little carbon, the material is stronger, can be tooled. Alloy steel are the most common of the elements, and we put inside of the steel materials other minerals to make it different and better. For example, the aluminum in steel will make this material like more smooth. The chromium in steel will be used for automobile and airplane parts because it's very hard, it's strong, it's elastic. Nickel is the most widely used of the alloys. And this is because the non-magnetic and has tensile properties of high carbon steel without the brittleness. Stainless steel also is very good because have a resistance to abrasion and corrosion and because have a high chromium content. Nickel was added to the stainless steel in order to make it better, like look better, to have a most polished surface. Also, it's possible to have something like an oxidation in the exterior part of the steel that will protect the interior to don't get oxidate, and that is what is called the weathering steel. Steel have many advantages as a build material. First, it's very light in proportions. Some people think how steel can be light because actually a piece of steel of the same proportions of a steel of any other material will be more dense and therefore will be heavier. Yes, that is true, but you need very little steel to make a building in comparison with concrete or any stone or any other material. Therefore, because the elements are smaller, at the end the material will be very light in proportions in comparison with the strength. It's also very strong and tough in proportion with the weight. The fabrication is done in controlled conditions. That means that there are very few mistakes because the material is made in a mill and therefore is controlled. That doesn't depend of the weather, that doesn't depends of mistakes of the person that is doing the material. Well, it's very precise, it's very predictable. Also, it's 100% recyclable. And by far is the largest percentage of any other material, and the largest percentage of new steel product produced in America is recycling scraps of steel. Well, it's a wonderful material for construction. One of the inconveniences of steel is that can be a little bit expensive. Let me go back 1 second here. Steel have also disadvantage. Steel has also disadvantage, and is that it will deteriorate due to rust if it is not protected. Prolonged exposure to high temperatures, fires will weaken the material. Even though the steel doesn't bore, the framework can move, and after intense heat can have problems. Steel have many shapes that can be used in construction, and there are standard steel shapes that are used to make beams, columns, and many other applications. Wide flange shapes, American standard, eye channels, angles, etc., etc., and we'll be studying them now. It's very important to understand the different type of shapes because we need to identify them and we need to understand what is the nomination, the name that each one of them has. The first one is the wide flange shape that we can look here in the right side. It's like an I-beam, but it's an I-beam that is like a square. The flanges at the top and the bottom are a width similar to the deep, how tall the beam is. The first shape of this type were called standard shapes. And that's why sometimes we will look that there are called S shapes. Well, they can be called S or wide. However, the S are the ones where the width of the flanges was narrow in comparison with the high. It's more like an I. However, the one that is like a square is like that is the one that is called W, that is wide flange. Structural techniques prove that the beam with a wider flange have the great load carrying capacity and resistant to deflections. Why that happens? We already spoke about that. When you have a beam that have this kind of form like a Y, you have a lot of material in the superior part and a lot of material in the inferior part. And you have less material in the center. The best beam will be something like this, one that have like no material or almost no material in the center and a lot of material in the inferior part and no material here. Why? Because here and here in the inferior and superior part, I mean in the top and the bottom of the beam, we will have, in a normal beam, we will have something like this. The beam will deform in this way when we have a load here. Therefore, here we have a lot of compression, here we have tension, and here we have an axis where nothing happens, where we need more material in the superior part and more material in the inferior part and very little material in the center. That's why this kind of beam is very convenient and is the most efficient of all of them. The steel is made always under control conditions according with the specifications of the American Society for Testing and Materials. This is the one that tells how the steel should be made and in what conditions should be made. There are two basic formulas for steel general construction that are made according with the strength. I mean, it's like two types of steel. One is called A36 steel, that is the standard, and has a strength of 36,000 psi. The other one is the steel A50, that is for multi-story buildings that have a yield that is higher, that is 50,000 psi. Well, steel structures are erect according with the specification of the Manual Steel Construction published by the American Institute of Steel Construction. Well, two things here. One, in the superior part, that the steel is manufactured according with American Society for Testing and Materials, but the steel design and fabrication is done after the material is ready. When we start building with that material, everything is done according with the American Institute of Steel Construction that published this steel manual. Well, there are two conditions: how it is made, the material, and how the buildings are made with that material that was already prepared. Well, we will look here some samples of the Manual of Steel Construction that will tell us the different type of steel. The steel have name, and the first number in the case of the W shape is W. That is the name of the steel. Y flange is the type of element. And after we have size and characteristic that depends, and everything will tell us what is going on. For example, W indicate the shape of the cross section. That is Y flange, that look like an I-beam but square. The first number indicates the nominal depth of the member, how tall the material is in section. And the second indicates the weight per line linear foot. You need to memorize these kind of denominations for every one of the different materials. For example, a W shape, that is this one, have a designation that you need to memorize. And the designation is W, type of steel 18, it will be the depth of the material D. Let me write here this. W is because this is a beam that is called Y flange. Yes, it has a form as an I-beam, but the I-beam is like this. This area is taller. Our W is like a square. Okay? And it's called W. That's the first number. W. The second number is 18. 18 is the depth of the material. And the other number is 119. 119 is the weight of 1 foot. We cut this, we cut here 1 foot, 1 foot, 1 foot of the material, and the weight of this material, only in 1 feet of this material, 1 linear feet, that weight is the second number. Weight is in pounds. And 18, that is 119, and 18 is in inches. Well, when we have a beam that is called, for example, 18 by 71 means this is a W beam, I mean an I beam, and after the height of this material is 18 inches, and the weight of 1 linear feet of this particular material will be 71. If we want something that is not so thick, well, it can become 75, 60, 55. That means in the section, this thickness will change because the weight of the material is smaller. The next example is called channel because have like a C shape, and in the American standard it's called channel, and it's according with the American standard denominations. The denomination is called C because it has the form of a C. The first number is the exact depth, how tall the material is, and the second number is the weight per linear foot. And well, we have here the material, and for example, this is just one example, we have a material that is called C12 by 30. That means it's a C channel with this form, this dimension, that is the height, is 12, and the weight of 1 linear feet of this material, this weight is exactly 30 pounds. The next one is called angles, and it's this one. Let me go back, and has a form of an L. This one have 4 types of numbers. First, L, and after 3 numbers. The first indicate the length of the longest leg, the second, the length of the short leg, and finally, the thickness of the legs. The weight of the angle per foot is not part of the designation. This is different. If we need to buy this material, you go to Home Depot and you take, I want an angle L, is the name of the angle, is L. 5 will be one of the legs. And let me write that here. This one, for example, will be 5. This one will be 3.5, and the thickness of that material will be 3/4. And it's called L because it do have the form of an L. We can have an L that have the same dimension. For example, this will be an L of 2 by 2 by 0.5, for example. Well, this will be an L, that's the first number. The second number will be 2. By coincidence, the next number is the same, and the third number will be the thickness, that is 0.5. Attention, it's no matter if the material is like this or the material is like that, because we know that the first number is the longest of the 2 sides of that L. Can be like this, and this will be always the first number, the longest one. Let me clear here and go to the next slide. The next one is called S shape. And this S shape actually is an I-beam. It was not used for framework in the past, is not as efficient as the W shape, but is used for things like crane, rails, warehouse, and also for some beams. S is followed by two numbers, and this is exactly like the W beam. I mean, an S beam is a beam that has the form of an I-beam, but is very elongated. It's not like the W, that is also called I-beam. Both of them are called I-beam, but this should be called S to be exact, and this should be called W because it's wide flange, because this flange is wide in comparison with this one. And well, this has the same denomination. We imagine that we have 1 foot of this particular material, for example, and this material will have a weight. Therefore, the denomination will be, for example, S, that is the form. Doesn't have the form of an S, but have the form of a long I-beam. Second 24 is this dimension. How tall or deep. Deepness is the same that how tall or high the material is. It's 24, and 121 is the weight in pounds of 1 foot of this material. Why the weight of pound? Because maybe this thickness is different to thickness. Well, in order to make this easier, we just have the weight. Why we use the weight? Very important question, because the weight is what we pay. We pay the material according how heavy it is. We buy the steel according how heavy it is. Well, if we look these pieces of steel, all of them are S. All of them are 24, but this is 80 and this is 121. Well, 80 has a cost of $80, for example, and 121 will have a cost of $121. Okay, it's more expensive because the quantity of steel is smaller in the one of 80. We buy the steel according with the weight. The next example is for pipes. We're going to have pipes, and there are many types of designations, but the typical one that we'll use are the 3 designations that have to do with the pipe size. Is the nominal inside diameter, followed by a second number that is the type of thickness that this wall material will have. Well, usually we have designations that are called standard, strong, and XX strong. And we'll have number according with that. For example, we have a pipe here, and this pipe have a standard weight, and from this pipe, what we will have is the nominal diameter and the outside diameter. Next, we have tubing that are square or rectangular cross sections, and they are called TS, following by a number that indicate the width of the longest side, then a number that indicate the width of the short side, and finally, a number that indicate the thickness of the wall. For example, a TS 6 by 4 by 1/4 will be something like this. First is TS, admin is an element that is like that and has an opening in the inside. It's a tube. And the tube have one side that is the longest one, that is 6. The shortest one that is, for example, 4. And after 1/4 is the thickness of the walls. We imagine that the thickness is the same for all the walls. And well, we have here several examples. We have an example of structural tubing that is 8 by 3 multiply 3/8. We have 8 by 3 by 3/8. Let me go and write that here. Let me go back. And we can look here that what will happen with this material is that we have the TS tubing that have 8 in this dimension, have 3 in this dimension, for example, and after it have 3/8, that is the thickness of the material. After we have a structural T. This is like a W shape divided by 2. It's something like this. We eliminate the inferior part of the flange. And it has also a designation that is very similar to what we looked before. And well, you will have a particular dimension of the height of this material, that is the first number, and the second number is the weight of 1/5 of that material. There are many other sections like HP shapes for columns, M shapes for things like specific elements that are using for wide flange, etc., etc. And we will not study them. The next chapter is about how we put this piece of steel together, and one possibility is to weld the steel. We will have a special chapter and presentation to understand all this concept, but the material, the steel, can be weld or bolt. Welding is when we weld 2 pieces. It's a labor-intensive element. It requires high skill and certified craftsmen. And it's important to make sure that it's well made. Bolting instead is easy, it's less labor intensive, usually can be made in the shops. The holes will be made, you buy the bolts and you just put together in the place. Well, it's easier to do in the place. Bolting is better to be done in controlled conditions. Well, the fact is that when we have a steel frame, we need to connect those columns and so on, and we can have connections. And we will study all those connections later on, but for the moment, we will understand only 2 types of connection. A simple connection is when we bolt part of the web. For example, here we have this particular column, and this column is attached. This column has an attachment that is this beam. And look, this beam is attached only in the central area. I mean, in the flange. This area is the flange of the material. Well, we attach the flange and we didn't attach the web members. They are like free. But if we attach the web members, for example, we just try to create like some kind of, for example, welding here and here, then all the 3 elements of an I-beam, the superior, the middle, and the inferior part are attached to the column. Well, in that moment, we have a moment connection that is stronger, will transmit shear and moment. The flange need to be connected, inferior and superior part, and may require some stiffener, I mean some elements here to allow this material to connect better. But that is something that we will study later on in a specific chapter. Let me clear everything. Also, we have other type of materials like open web joists that are called bar joists to support floors, roof, and the joists have a specific spacing, and we will have a chapter like a specific class where we will study them, and we will understand how they work and what are the dimensions. Usually they are a classification, and the classification is very simple. We have K, L, H, and DHL steel joists, open web steel joists, and K is the one until up to 60 feet. LH are the medium span on up to 96 feet, and the LH are the ones with longer span that is up to 144 feet. You need to memorize those numbers. Well, we can look here that the joists are used for floor support, but we will study joists later on with more details. We can look here what is a joist seized, what is a joist girder, that is this area there. And also we have trusses that can be very heavy and large, and that's something that we'll be looking later on because there are convenience when we have very long spans. When we speak about steel and long span, trusses are the most convenient material, and they're used in stadiums and many other type of buildings. Finally, we will be studying steel decking. I mean, how we can make the floor also out of steel, and how the steel can be used also for roof material, or how it can be combined with concrete. And that is something that we'll be looking in other classes. Finally, steel need to be fireproof because steel have problems, and there are many ways to protect that steel to don't be in contact with the fires. And you will see that in the United States, unfortunately, it's very difficult to make now buildings like those towers that were destroyed in September 11 in New York, because the steel was unprotected and the steel was outside. Well, nowadays it's impossible to make tall buildings if the steel is not protected. Well, normally there is concrete or masonry around, there is plaster, there is drywall, spray of fireproofing combinations, mastics, etc., that will be around. For example, in this case, we have a fireproofing that is sprayed in the members of steel, and they don't look good. We don't look the material anymore. We need to cover this material in some way. And it's a shame, but it's necessary because they still have problems with high heat. Also, something interesting with the steel is that we have standard elements, but we can modify them, we can bend them, we can like weld several pieces and have elements that are very interesting, like the ones that we are looking here. Well, the fact that we are speaking about steel doesn't means that the material will be a boring one. It can be a wonderful material that can make curvilinear structures that are very interesting. And that will conclude this presentation.